Here we have a grid that represents a street map, and we're wondering, in how many ways can you go from point X to point Y, walking the shortest possible distance? So in other words, in how many different ways can you walk 1, 2, 3, 4, 5 blocks to get from X to Y? Well, there are a couple ways to think about this question. And at first you might try, and practically everybody tries, to think of some ways to do it. So maybe I could go here, and then up here, and then here. Or maybe I could go here, 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 here. And it becomes pretty clear pretty quickly that it's going to take a long time to solve the problem that way. Well, here's a way to think about it. And I'll erase the yellow markings. We're going to be walking 5 blocks here. And we're going to walk, I'll write up here, east twice. So E and E. And then north 3 times. So I'll have an N, an N, and an N. Let's consider those to be 5 steps. And now we'll think about this in the same way we thought about similar problems. I have, let's see, 1, 2, 3, 4, 5 steps. I want to know all the different ways in which you could arrange E, N, N, and N, but without overcounting anything. We see 2 E's here. We see 3 N's here. We have repeating letters, repeating elements. We don't want to overcount anything. So how do we want to handle this? Well, for the moment, we'll pretend it's a traditional permutations question. The first step could be any one of 5, and then 4 times 3, 2, 1, which turns out to be 120 different ways to walk from X to Y if you took 5 steps. Well, now, of course, that's way too many. We have to divide here, and we divide by what? The 2 E's, so that's going to be 2 factorial, and the 3 N's, so that's going to be 3 factorial. I'll write it down here again. It's going to be this. We'll divide by 2, and then we'll divide by 3 times 2 times 1. 3, 2, 1 cancel on the top and the bottom. We have on the top what? 5 times 4, 20 divided by 2, 10. 10 ways in which to walk from X to Y. So that's one way to think about this question. That's one way to solve this question. Here's another way we could do it, and this is the way most people think to do it. Suppose we do try to count this, but we figure out an efficient way to do it. What do I mean? Well, let's see, starting from X, suppose we went 1 block east. All right, how about our second step toward the east? Well, it could be here, or here, or here, or here. In that scenario, there are what? 4 different ways. 4 different ways to move east from X to Y. Okay, so we'll erase the yellow marks and look at a second group of arrangements. Suppose that we're here at 2nd Street that we began walking east. Then our second step toward the east, it could be here, or here, or here. It could be in one of 3 places. So I'll add 3. All right, we'll keep going with this. If we walked up to 3rd Street before we then started walking east, we could go 1 step, 2 steps, or 1 step, 2nd step up here. That's 2 more ways to get there. And then the final route, you walk north 3 blocks up to 4th Street, and then you go 1, 2 blocks east. So we'll add a 1 over here. And those add up to what? 4 plus 3 plus 2 plus 1, that is 10. 10 different routes we could take. Most people probably solve the problem that way. But the first way we did it, we're going to use this approach in solving a similar problem in the next video.